Let's have a look at the Kreosans Tesla coil, or actually what he calls it Tesla chair. They're using to generate very high voltages from a pretty simple circuit. In this video we're gonna have a look at the circuit diagram and the Tesla coil that I have built with the same schematic, but with minor modifications. Here we can see my coil, and here we got the control switches here. We got some fuses. I'm not actually using the SCR circuit, I'm just using a 555 timer to pulse the Tesla coil. And you can see the potentiometers for controlling the PWM and the frequency. We got the main switching transistors under this heatsink, and there's the solid state relay. There's the transformer for the 555 timer. Got a mains fuse here and a secondary fuse for the transformer. Here's the top part of the Tesla coil. It's from a little flywheel from a VHS. There's the capstan coming out there. I'm using it as a top load. Here we can see the 4 turns of primary, and there is 1300 turns, maybe a bit more, maybe a bit less, of secondary. I couldn't make it as good as Kreosans Tesla coil, but it actually works. It actually does something, but not so spectacular. So let's plug it in. I have it on 125 watts. And yes, you can see some sparks there. Let's bring this one close to it. Let's try with 250 watts. They didn't get so much longer, but a little bit. I can actually feel that. That actually hurts a bit. Let's change the frequency a bit. Here we go. The cold cathode fluorescent light. Now we can see it a bit better. Bringing this copper wire close to it. See, there are some sparks coming out of that. Let's change the frequency. Let's turn down the power again. It's not so much difference in the size. It's a little bit longer. The circuit actually has another switch. If I turn it on, and if I turn the switch on, not so much is happening when I turn it on. Maybe a little bit longer sparks, but it's very negligible. The big difference is when I bring this copper wire close to it, this happens. It stops pulsing. When I disconnect the switch again, it continues pulsing. The switch on, it stops pulsing. It's a bit strange. And here I have opened it up so you can see what's inside of it. Got the transformer here, 555 circuit, and this port for a Slayer exciter and the protection circuits. We've got the big transistors underneath here. Let's see if I call this Tesla coil for a Slayer exciter. Here's a normal schematic of a Slayer exciter. We got the secondary here with a little capacitance through the top load to ground. We got the primary, a bipolar transistor, a biasing resistor here, and the LED. So when you turn it on, the transistor turns on as well, and current rushes through here, through the transistor, and into the negative, and this will charge the secondary, and while the secondary is charging, it pulls the base down, so it shuts the transistor off. And this LED here is so that the current passing through the secondary can go through this LED and not through the transistor and damaging it, because this can be pretty high voltage here. And when there is no magnetic field left here and all charges are gone, the transistor will turn on again by the current passing through this resistor here, and the cycle repeats. Let's have a close look at Kreosans circuit here. We got this part here. I couldn't get this part to work. This is what pulses the Tesla coil. It's a SCR and a triggering circuit. The triggering circuit is a resistor here, 10K, charging this capacitor. When the capacitor charges and reaches a threshold voltage of this SCR, it starts conducting and shorting these components out, and it turns off in the next half cycle. And the cycle repeats here. Starts charging it up and triggers the SCR, discharging it. Goes through this fast diode. I don't know why this fast diode should be here. I used a normal diode here. And here's the part with the switch that I didn't know how to use it. When I bring the wire close to it, it stopped pulsing. And after this it goes through two ballasts. Power switch here. Got a filtering capacitor. It's not a smoothing capacitor, it's just a little filtering capacitor for removing some interference. And here we got the secondary and the primary. Again, the secondary is connected to the gate of this MOSFET. This is a MOSFET this time. And we got the resistor here, biasing resistor. And in this case, we got a resistor here, which acts as a voltage divider with this resistor up here and this protection device. We got a what looks like some kind of a snubber network with no capacitor. We got a diode here and two resistors, 51 ohms. And on the drain on the transistor, we got some more protection here. We got a diode and one of these protection diodes here as well, which is just like two Zener diodes connected in series like this. This one is a 400 volt protection diode. You can change this component depending on how much voltage the switching device can handle. So maybe some IGBTs can handle more than 15 volts, and maybe some MOSFETs cannot handle 15 volts. You need to have like a 10 volt here instead. Let's have a look at my circuit. It's on the other side of it. Here you can see my circuit. The different part is this one, which is the 555 timer and the solid state relay, because I couldn't get the SCR circuit to work. I use a normal diode here instead of a fast diode. Here's my ballast, 125 watts, and another one here. I can change that switch to 70 watts or to 125 watts. And maybe put a third ballast here instead of this, because it doesn't do any difference. I got an 18 volt protection device here, and using two IGBTs, some gate resistors. It's a collector protection circuit with a 400 volt protection diode and a diode here. I've written here 5 turns, but it's actually 4 turns. This is a large primary, or secondary I mean. Here's a different part. I used another type of resistor here, a 330 ohm resistor. I tried with the two 51 ohm resistors and it worked terribly bad. So use this one instead. Don't know why that was. And here you can see the two ballasts in here. And here is the solid state relay. And here underneath the plexiglass you can see the two IGBT transistors. And the plexiglass is from old LCD monitor. And the tubes I wound the wire around are just ordinary PVC drain pipe. Yes, hope you found this video interesting. Thanks for watching.